Hello and welcome with you guys in our Transit Autonomous System video series. In the previous video, we have discussed point-to-point network connection types. Then we have performed a small lab explaining how can we connect two network nodes together using a point-to-point connection and to have a successful reachability between both of these nodes. Can you differentiate between these two network setups, the one on the left and the other on the right? The one on the left, it is the point to multi-point network setup, but the one on the right, it is a multi-point to point network connection, which is known as router on a stack network setup. And we will discuss this type later on in this video. Now we will discuss point to multi-point network connection type. When one device is connected to many different devices through a centralized device like the figure below. You can see main router is connected to R1, R2 and R3 through the centralized device here, which is switch S1. So in this setup, main can reach to R1, R2 and R3. R1 can reach to main, R2 and R3. R2 can reach to main, R1 and R3. R3 can reach to main, R1 and R2. So all of these devices can reach to each other at the same time. So all devices here will be considered in the same broadcast domain. All devices are in the same network, so any device can reach to any network can be reached by any of the other devices. This is our point to multipoint lab. As you can see, main router will communicate with these three routers on the right, R1, R2 and R3 through switch S1. Let's start our configuration. From main router side, we will configure the point-to-point connections between each router and the switch, starting from main router. Global configuration mode, interface Ether 0/0. First of all, we will type do show IP interface brief to show the state of the interface. As you can see, Ether 0/0 is administratively down, so no shut. The state of the interface has been changed to up. Then we will type the IP address, which is 172.29.25.1, 255.255.255.0, which is representing /24 mask. Then here we will force the duplex to be full like we have done in the first video, the point-to-point connections, as these are VMs which may not negotiate to the right duplex. So there may be some difference between each component and the other, so we will force it to full duplex overall. Let's move to R1. Interface Ether 0/1. Same thing, do show IP interface brief, Ether 0/1, it is administratively down, so no shut. Interface state has been changed to up. IP address 172.29.25.2, and the same mask. Then duplex full. Okay, right, let's see, okay. As you can see, a notification message for duplex mismatching. The same message from main router side, which is mean there is a duplex mismatch between R1 with the switch S1. So we will configure the interface range here from Ether 0 to Ether 3 to be duplex full to have the same state with main R1. As you can see, another message has been generated. Let's move to R2. Configure. Interface Ether 0/2. No shutdown. Interface state has been changed to up. IP address 172.29.25.3 255.255.255.0, the same mask like others, then duplex full. Let's move to R3. Configure terminal. Interface Ether 0/3. No shut. IP address 172.29.25.4 255.255.255.0, duplex full. Do right to save the configuration. Now, let's have our troubleshooting. Before we start, we have to check the MAC address table from switch 1 side. As you can see here, this is the MAC address table divided to 4 columns. The last one refers to the ports from which the switch have learned about these MAC addresses. The first one refers to the VLANs in which these ports are members. The second refers to the MAC addresses themselves, related to the hardware network interface cards interfacing the devices directly connected with S1, which are main router, R1, R2, and R3. And finally, the third one, which refers to how S1 learned about these MAC addresses, either by dynamic way or statically by configuration. Now let's go to main router. Let's show the ARP table from main router side. Show IP ARP. Here in the ARP table you can find one entry representing the local data where the local IP 172.29.25.1 and the local MAC address with the exit interface Ether 0/0. Okay, so now we will ping to R1. Ping 172.29.25.2. We got successful ping. Let's show again the ARP table. A new entry has been added representing the path toward R1. Now we will try to ping R2. Ping 172.29.25.3. Yes, we got successful ping. Again, let's check the ARP table. A new entry has been added. Again, toward R3. Yes, we got successful ping. And now a new entry has been added representing the path toward R3. If you can see, these MAC addresses found in the ARP table from a main router side. From R1 side, let's show the ARP table. We'll find only the entries representing the path toward the main router and the local IP, which is 172.29.25.1 and 172.29.25.2. Let's try to reach R2. Yes, a successful ping, as we are in the same broadcast domain. We are in the same network. So we got successful ping here, and we will check the ARP table also, and we will check the ARP table here too. As you can see, a new entry added representing the path toward R2. Let's try R3. Yes, we got a successful ping. So here we are having all the routers can reach to each others in this point multipoint setup. R1 can reach to R2 and R3 and main router. Main can reach to R1, R2 and R3. R2 can reach to main, R1, R3. All of these can reach to each others. Multi-point to point or router on a stick. When one device is connected to many different devices through a centralized device like switch S1 here, just physically. However, in fact, every two devices are connected in point-to-point setup and separated from other devices on VLAN scale. This is our lab. Here we are having our setup physically similar to such of the point to multipoint lab. However, both are totally different. Where our lab here is a group of multi-point to point connections separated on VLAN scale by switch S1. This setup is known by router on a stick, where main router here is the router on a stick, which is having three separate point-to-point connections with R1, R2, and R3. Here is from switch 1 side. We'll configure three VLANs, VLAN 2, VLAN 3, VLAN 4, to separate between the three buses between main router, R1, R2, and R3. For R1 path, we will use VLAN 2. For R2 path, we will use VLAN 3. For R3 path, we will use VLAN 4. So here for R1 path, all switch 1 ports direct connected to main router and R1 must be members in VLAN 2. For R2 path, all S1 ports direct connected to main router and R2 must be members in VLAN 3. For R3 path, all S1 ports direct connected to main router and R3 must be members in VLAN 4. From main router side, sub-interfaces with single VLAN tagging with the same VLANs representing R1, R2, and R3 buses will be created under interface Ether 0 over 0. We'll configure the main interface Ether 0 over 0, duplex full. Then here we will create three sub-interfaces under the three VLANs. We will use VLAN 2, VLAN 3, VLAN 4. Each one of these sub-interfaces will represent the exit interface toward its corresponding router. The first one corresponding to R1 under VLAN 2. The second one under VLAN 3 corresponding to router 2. The third under VLAN 4, the sub-interface corresponding to R3. Interface Ether 0 over 0 .2 capsulation .1q. After .1q we type the VLAN IP address 172.29.25.1 255.255.255.252, which is representing /30 mask. Here we will move to the next one, interface Ether 0 over 0 .3 capsulation.1q3, then IP address 172.29.25.5 255.255.255.252. Then we're gonna move to the next and last one, interface Ether 0 over 0 .4 capsulation.1q4 IP address 172.29.25.9 255.255.255.252. Then do right to save the configuration. Let's move to switch S1. Here show VLAN summary to show how many VLANs being configured on this switch database. To show these VLANs, we type show VLAN brief. As you can see, we have configured VLAN 2, 3, and 4 in this switch database. Then show run interface Ether 0 over 0. We have configured Ether 0 over 0 port as a trunk interface, where all VLAN range is allowed from 1 to 4094. Then show run interface Ether 0 over 1, the same. Here all interfaces to be trunk in all VLANs, so all VLANs will be allowed. We will do the same for interface Ether0/2. Then we will repeat that for interface Ether0/3. Let's move to R1. From R1 side, configure interface Ether0/1. We'll force the duplex. Then we will create the sub-interface encapsulation.1q2 IP address 172.29.25.2 255.255.255.252. Right? Let's move to R2. We'll do the same here. Interface Ether0/2. Duplex full. Interface Ether0/2.3. Encapsulation.1q3. IP address 172.29.25.6 255.255.255.252. Do right. Let's repeat this with R3. Okay, configure interface Ether0/3 duplex full. Then we will configure the sub-interface. Interface Ether0/3.4 encapsulation.1q4 IP address 172.29.25.10 255.255.255.252. Do right. Let's move to troubleshooting from main router side. Show IP interface brief. As you can see, these are the sub-interfaces under Ether0/0. From R1 side, show IP interface brief. As you can see, Ether0/1, the sub-interface Ether0/1.2. From R2 side, show IP interface brief, the same, Ether0/2.3, and the same from R3 side. From switch 1 side, show MAC address table. As you can see, here the MAC address table for VLAN 1, we can get the MAC addresses from these 4 ports 0/0, 0/1, 0/2, 0/3. For VLAN 2, 3, and 4, we just are having the MAC addresses related to R1, R2, and R3 learned from Ether0/1, Ether0/2, Ether0/3. So let's compare this with the result after we test the reachability between main router and the 3 routers R1, R2, and R3 separately. Okay, from main router side, ping 172.29.25.2. Yes, we got successful ping. Can you notice this MAC address, which is learned from Ether0/0 related to main router, and how it will appear again under VLAN 2 in the same MAC address table? So let's find out. Here on showing the last updated ARP table of main router, there are 2 entries representing the path from main router and R1, including layer 2 addresses, layer 3 addresses, and the local interface from which these addresses are being learned. Let's repeat the same troubleshooting with R2 and R3. For R2, load 6. Yes, successful ping. So let's check the ARP table. This is a new entry being added for R2 path. Let's check MAC address table from switch 1. A new entry has been added representing the path between main router and R2, as same as that we discussed with R1. Now let's check R3. Successful ping. Again show ARP. A new entry has been added representing the path toward R3. So let's check the MAC address table from switch 1 side. The MAC address table here has been updated with a new entry under VLAN 4 with interface Ether040. Now from R1 side, let's try reaching to R2. Ping 172.29.25.6. As you can see, no successful ping. Like we have got in our point to multipoint lab, which is a proof on difference between both point to multipoint and multi-point to point connection topologies. And when we apply show IPR from R1 side, we will find the old entries representing the point-to-point connection between main router and this R1, and no new entry representing the path toward R2. To differentiate between both, we can commit that in point-to-point setup, all devices interfaces are members in the same subnet and the same VLAN, while in router on stick, only group of 2 or more of these devices interfaces are members in the same subnet and the same VLAN, which is different from that of the others, and the switch will perform the separation between all of them. By the end of this video, you have got the knowledge about the connection types we will use in our transit autonomous system building. Point to point in the previous video, point to multipoint in the beginning of this video, and how it differs from multi-point to point or router on stick connections. Thanks for watching. Don't forget to subscribe our channel, like, and share our videos. See you again.